Module 17.4, Day 2. Similarity in right triangles. Content standard. Prove theorems about triangles. Language objective. Explain to a partner how to use the angle-angle criterion to show similarity in triangles. Using the geometric mean theorem. You can use the geometric mean theorem to find unknown segment length in a right triangle. Example 3, find the indicated value. So we're solving for x. So let's start from here. We can use the ratio from day 1. So we said 10 over x, x over 2. So we can say 10 over x equal to x over 2. And then from there we can use our cross product. So 10 times 2 equal to x times x, which is x squared. So we have 20 equal to x squared. So to solve for x, we take the square root of both sides. So the square root and the square, they cancel out. And 20 can be written as square root of 4 times square root of 5 equal to x. So which is 2 radical 5 equal to x. Okay, now to solve for z. So then let me redraw the figure from example A. So we have this, and this is y, this is z, and this is 10, and this is 2. And we're given x as 2 radical 5. So this is 2 radical 5. So then to solve for y, we can start from here. So we can say 10 over y, go backward, y over 12. So we say 10 over y equal to y over 12. And then we can use our cross. We can use our cross product. So then here we have 10 times 12 equal to y times y. So then would be 120 equal to y squared. So then to solve, we take the square root from both sides. So that cancel out. So then the square root of 20, we can break this up into square root of 10 times square root of 12 equal to y, and becomes square root of 2 times square root of 5 times square root of 4 times square root of 3 equal to y. And the only one that we can reduce is 4. So this gives us 2. And 2, 5, and 3, those are prime numbers, so we cannot reduce those. So then we do 2 times 5 is 10, times 3 is 30. So the answer for y is 2 radical 30. Right? Okay, so here an easy way to remember this is that whenever you have one of these, right? And let me erase that. Let me do this better. Okay, and this is a right angle, right? So let's call this A, B, C, D, and E. So the ratio is this. You can go from A to B, B to C. So then A over B equal to B over C, right? Or if you want to solve for D, then start from here. You can C to D, and D all the way to AC. So then we say C over D equal to D over C plus A. Right? And if you want to solve for E, then you start from where A is. So A to E, and E over AC. So we say A over E equal to E over A plus C. So these are the three ratios that we use. Right? Okay, so then for number 9, discuss how you check your answers. So to check your answer, to undo the square root, we square both sides. Right? So we know that the square and the square root, they cancel each other out, they become 1. Okay, So here we're going to solve for x, right? So then we start from where 5 is, so it says 5 over x, x over 7. And then using the cross product, so we have 35 equal to x squared. So we take the square root of both sides. So then the square root and the square, they cancel out. So we have x is equal to square root of 35. And then 5 and 7 are prime numbers, so we cannot reduce the square root of 35, so you leave it as is. Alright, okay, so now let's solve for y. Alright, so to solve for y, you start from where 5 is, so we go 5. You go 5 to y, and y to 5 plus 7 gives us 12. So we said 5 over y equal to y over 12. And then you use your cross product. So we have 5 times 12 equal to y times y, which gives us y squared. So we take the square root of 5 times 12 equal to square root y squared. They reduce. So this gives us y. Well, then we can break this up into square root of 5 times square root of 3 times square root of 4. And square root of 4 can be reduced, so it gives us 2. And square root of 5 and 3 would give us 15. So y is equal to 2 radical 15. Right, okay, and similarly we can use that same ratio to solve for z. Right, so start from a 7 to z and z over 12. So we said 7 over z equal to z over 7 plus 5 gives us 12. So then this gives us 7 times 12 equal to z squared. Take the square root. So this is square root of 7 times square root of 3 times square root of 4 equal to z. Square root of 4 can be reduced to give us 2. Square root of 21 equal to z. So we have the answer for z, y, and x. Okay, so then similarly here you are to solve for x, y, and z. So actually to solve for x we have 5 over x, x over 7. So then 35 equal to x squared, so then x equal to square root of 35. Okay, and then to solve for y, so we said 5 over y and y over 12. So then 5 times 12 equal to y squared. So square root of 5 times 12 equal to y. And we can break this up into 5 times square root of 3 times square root of 4 equal to y. So then the answer for y equal to 2 square root of 15. Right. Okay. So let's solve for z. So start from 7 to z and z over 12. So we do 7 over z equal to z over 12. So 7 times 12 equal to z squared. Take the square root. And 12 the same as 3 times 4. Right, we can reduce the 4, so z is equal to 2 square root of 21. Right, so this is the exact same problem from the previous one. Okay, so then I want you guys to try out number 13 on your own. And square root of 6 is the same as square root of 3 times square root of 2. Square root of 3 and square root of 5 give us x. Then these are the same, so they become 3. Square root 2 and 5 are prime, so then it's 10, give us x. Okay, so then for number 13, x is equal to 3 square root of 10. Right, and then to solve for y, so we start from 15, so 15 to y, and y to 21. So we said 15 over y equal to y over 21. So this gives us 15 times 21 equal to y squared. So take the square root. Square root of 15 times square root of 21 equal to y. So 15 is the same as 3 times 5, and 21 is 3 times 7. So here it's square root of 3, square root of 3, so they reduce to 3, and 5 and 7 cannot be reduced, so then square root of 35 give us y. Okay, and now let's solve for z. Right, so it goes 6 to z and z over 21. So we write 6 over z equal to z over 21. So doing the cross product, so 6 times 21 equal to z squared. So take the square root, so square root of 6 times square root of 21 equal to z. So square root of 6 is same as square root of 3 times square root of 2. Square root of 21 is square root of 3 times square root of 7. And square root of 3, square root of 3 reduced to 3. 2 and 7 are prime, so this is square root of 14. Okay, so then that's the answer for z. Right, okay, similar here for number 11 and 14. Right, so here then we don't know what this number is, but then we can solve for y first. Right, so for y we look at this, and this is a right triangle, and this is your hypotenuse, and these two are your the two legs. Okay, so let's solve for y first. So we say that 10 squared plus y squared equal to 20 squared. So that means that 10 squared is equal to 20 squared minus 10 squared. So from there you can use our calculator to work this out. So this gives us y squared equal to 300. So reduce that by taking the square root. So this becomes 10 radical 3. Right? Okay, so we know that y is 10 radical 3. So then from there we can use that to solve for x. So we can say 10. So 10 over 10 radical 3, 10 radical 3 over x. And we can say 10 over 10 radical 3 equal to 10 radical 3 over x. Right, so then 10 and 10 can be reduced, so we're using the cross product. So then x equal to radical 3 times 10 radical 3. So this gives us 3 times 10, so x equal to 30. Right. Okay, so let me erase these out. So we know that x is 30, so then from there we can use to solve for z. So we said 30 over z, z over 40. So we said 30 over z equal to z over 40. So then 30 times 40 equal to z squared. Take the square root, so square root of 30 times square root of 40 equal to z. So then this is square root of 10 times square root of 3, square root of 4 times square root of 10 equal to z. And square root of 10 reduced to 10. And square root of 4 is 2, so this is, right, so then z is equal to 20 square root of 3. Right? Okay, and for number 14. Okay, so for number 14, similar to number 11, solve for y first. So that's a right angle, so this is our hypotenuse. So we said 25 squared plus y squared equal to 65 squared. So then y squared equal to 65 squared minus 25 squared. So use your calculator for that. So this gives us y squared equal to 3,600. So then solve for so then y equal to square root of 3,600 reduced to 60. Right, okay, so let me clean up this part. So we're given that y is 60. So from there we can solve for x. So we said 25 over 60, 60 over x. And then use our cross product. So then 25 times x equal to 60 times 60. And so then x equal to 60 times 60 divided by 25. Okay, so then x is equal to 144. Okay, so let me clean this up. So x is 1. So x is 144. So from there we can solve for y. So then we go 144 to z and z to 144 plus 125. So then 144 over z equal to z over 144 plus 125 is 169. Right, so then 144 times 169 equal to z squared. So take the square root, so square root of 144 and square root of 169 equal to z. And 144 is 12 and 169 is 13. So z equal to 12 times 13. Oh, I think I made a mistake here. Let me see. So then z is equal to 156. Okay. All right, so that's the end of our 17.4 day 2 note. So your assignment is number 10 to 20, and you are to finish your HRW and turn them in.